Hi, Mr. Tiger 20, non-auto hop player. Was it sideways? I can never remember those styles. The least popular style. Backwards? Masochist. This is the game I was playing yesterday called Wreckfest. The config file is like you have to like host your own server. Wow, it's already hot. I can open a window as well. You have to host your own server, and it's like kind of hard. When you click host on your computer, it doesn't work. So I had to like set it up on my server, and it did work. And then like you have to make it so that the map changes, and there's like a cycle of maps. You have to manually specify every single one using the internal name inside the game, which like I found a list online, but bruh. Bruh. Alright, I'm gonna open the window. I kind of was wanting to play the game more instead of streaming, but I'll do at least 3 hours of work. I can at least do that much. Ugh. Is that pipe or wire running behind you? You see, my Linux user brain immediately goes to pipe wire, which is some software that is like running my audio. Oh, wait, it was on? Wait, the capacitors didn't discharge. It remembered what setting it was on. Usually it forgets. That's some old technology. Hell yeah. It's wire. Cord. Extension cord. Oh my god, that's right. Oh my god, the transpose. What the hell was I? Oh my god. And I also wanted to go deeper with the dot product as well to avoid another copy. It's worth it. What earphones? I don't know. There's some garbage I got from. I don't even know how I got these. I just found them lying around. My headphones broke. So I was like taking them apart to try and fix them. The cord has like a flaky point right here. They lasted for like 10 years. So That was nice. But then they broke. And that was not nice. I'm considering just buying new ones instead of... Bro. Bro, sit. There we go. Instead of trying to fix them. I'm not very handy, I must say. My dad is very handy. I'm only a computer handyman. This is macro hell. Okay. Fresh eyes, iteration brain. All I heard is my dad is very handy. He is. Okay, so this what is that? Oh, I see. That's what I'm doing right now. This is the outer struct. So what's going on? This is a matrix multiplication. So you have some matrix of some shape. It's a matrix 3 of vector 4s. So it's a 3 by 4 matrix. You weren't audible? Are very quiet? What? Ah! Who is turning down the volume? The volume is literally turned down. What? Why? What is turning down the volume? I thought it was a bug before. Bro. Oh, what song is this? Linux audio. For real, for real. Linux audio was shambles. Shambles since the beginning. And it's only recently that it has felt stable. And like it doesn't break all the time. I gotta find out what the hell that is caused by though. There's a meme. Linux meme, does your audio work? Oh, come on. Is it do you miss Windows? There it is. Do you miss Windows? No. Is your audio working? Okay, so I was explaining this. So this is a matrix multiplication. There's a matrix on the left and a matrix on the right. You're doing matrix A times matrix B, and they can have different shapes. So this one is shaped 3 by 4, and this one is shaped 4 by 2. And then when you multiply those, you get a matrix that's 3 by 2. The The 2 goes inside, and the 3 comes from the outside. And then these have to be the same size. So there's 3 degrees of freedom. And that's reflected by these 3 struct field thingies. So this one, this line represents this leftmost matrix. This is the inner struct for the left, the inner vector. And then this one is the right-hand side inner field, because the right-hand side outer field is just the equivalently sized matrix of this inner field. So right here, matrix inner, that's the same as this. Yeah, and then RHS struct inner is this, and then matrix inner is not needed, or apparently. But so it's a vector. It stays a vector. Okay. So how? So I need to pass through some stuff. So struct outer, result matrix shape. Okay, so struct outer, and then the RHS struct inner. So that's like, oh, it's going to look like this. And then the inner loop shape is what, this? Vec4, Mat4? Wouldn't that be like, oh yeah, struct inner, matrix inner. There it is. Okay. We have to use Linux with Vim. I feel like God maneuvering through it. It's very conceptual, like using the command line. Like you just need to know a bunch of different commands, and you need to like remember where you are in the file system, and like, so like print working directory. Oh, there I am. What's in this directory? List. Oh, it's that. Well, let's change directory to this random folder, and there's nothing in here. And you like, there's like a bunch of context that's relevant to like terminal stuff. I can see why it's intimidating, because like what do I type? What do I type? what do I do? But like there's rules, and like everything makes sense once you know it. Clear. The first, like, the biggest rule is that the first word is always some binary. So like PWD, the first thing that I did is actually a binary. So it's like an exe file. It's always a named exe that you're running to like perform some action, and then it has some sort of help, and you can like ask what you can do with this command. Rules. Seller. So it's not like you're magically just instructing the computer to do something. You're running applications, but they're just terminal applications. But that's not obvious. Definitely not when it's your first time seeing a command line. Okay, so when you do the matrix. So okay, the resulting matrix will have 3 components. and that is, it's using the transpose of the right hand side matrix. Okay, let's write this down. So it goes like RHS transpose, and it becomes mat2 vec4. So this is transposed from 4 by 2 to 2 by 4. And then after that, each these are like indexed as X and Y, and then these are dot producted. So it's like out. So it's 3 by 2. So if we start at the first element, that is equal to this is the left-hand side, so it's left-hand side element 0. So this is like the first vector 4 of 3 vector 4s, and then the right-hand side dot. It's like also the first vector 4 of 3 vector 4. So this is like, this is X, and this is Y. No, this is Y. This is X. So that's what I'm trying to write above. Okay, so why don't we do, let's name some stuff. Left hand side equals it equals this. Right hand side equals that. And then if we do right hand side transpose, I guess I'll say that. So out equals this. Final loop. Okay, this is the inner loop. Okay, RHS is there, LHS is there, and out is there. Okay, so that's maybe clearer. So why don't I do this? Doot, scoot, boom. So left-hand side dot product, right-hand side becomes out. And then let's say left-hand side is this, right-hand side is this. I guess I could put it like this. And then how to matrix multiply. Take the transpose of the right-hand side. So the transpose of the right-hand side is, if it's 4 by 2, then it becomes 2 by 4. And then for each y and x, take a left-hand side axis and take the dot product with a transposed right-hand side axis. So instead of taking a row, you take a column from the right-hand side. And that's it. Okay, I'm gonna not do that. Okay, so this is okay. Yeah. Okay. What's going on? Okay, so there's two loops here. I have this outer macro, and that is building the outer struct. So that means that it's looping over Y. And it means that the right-hand side is constant. So in here, yes, so I'm saying, hey, take this field from the left-hand side, do the dot product with something insane from the right-hand side. Because I have to do the transpose axis. Okay, so I'm receiving I'm gonna put these comments. Yeah, this is okay. Okay, so matrix inner. Oh, is that just totally wrong? I put the left-hand side in matrix inner. Okay, so what's going on? Inner loop shape. Okay, so we have struct inner, matrix inner. So this is not correct. This is like matrix inner. Oh, do I not need that? So what I need is a transposed vector from the right-hand side. It's a vec4. So that's literally just this. So I don't think I need this at all. Oh. Well, right. So I need, okay, I see. I need to read from the right-hand side matrix. Okay, so this is actually wrong then. Uh, um, uh, oh, wait, that is the right-hand side matrix shape. Oh, oh. Oh. Okay. So when I say inner loop shape, what the flying hell does that mean? Uh, I see. So this is either wrong or mislabeled. Okay. So what the tarnation is happening then? So I need to take the dot product of this with some transposed uh, lifted right hand side. So how do I what do I need to do that? So I need to read from the right hand side matrix, read from the right hand side struct, and then construct construct LHS construct something the same shape as this to do the dot product with. helper. Hmm. So this is a builder that's building a transposed axis. Okay, we need to track the fields here. Bruh. Okay, why don't I just start labeling? Just go for it. Okay, so let's see. Struct inner is vecx. Why do I be doing like that? Okay, whatever. RHS struct inner is vecgz. RHS matrix is matx. Why doesn't it happen here? Okay, well, I guess it's not in a macro. Okay, so I'll just paste the same labels up here. You can unselect. Why did it? Oh. Okay. RHS outer. Struct inner. Oh, is that not correct? RHS struct inner vecx. Yeah, that's not correct. Ugh. Okay. So vecx is LHS struct inner. So if I swap these, it's good to go, right? So yeah, RHS struct inner, struct inner. Okay, okay, now it's lagging. Wonderful. RHS field outer. That doesn't sound right. That doesn't sound right at all. So the it's taking different RHS fields. It needs the full thing only. I don't think it needs that. Okay, shh. Yeah. Because it's not taking a static field. The field is dynamic. It's not taking a single field here. Yeah, that's the wrong static field. Oh, oh. Okay, where is the RHS struct inner? We need that one. These are the same size. No, they're not. Where did it go? Am I not passing the right thing? Okay, this is vecx matx. So I need that for both. Field inner is the static field. Please, sir. Please, sir. Ah! Ah! I thought I had it. I was so right yesterday. I was not gonna get this, and I am stepping through this like a machine right now. Okay, what does it say? What do you want? It's still doing it? Is this wrong? Struct outer, RHS struct inner. Is that right? It says struct outer, RHS struct inner. No, that looks right. What is this building? This is building struct inner. Vec x. Doesn't it need to build? RHS? What? Yeah. So, okay. What is struct inner is vec x? Does that have anything to do with it? No. No. Well, it's built. It's building this for the dot product. So this needs to be passed into here. So where? Oh, come on, come back! My God, the crashing is not nice. Could we just chill for a minute? Okay. Okay, so this struct needs to be struct inner. Yeah, you see it's nowhere there. Okay, so this needs to be the opposite way around. No way. Oh my God, I have to trace it again. But I can see the whole thing now. Okay, the labels are wrong now. Inner. Please don't crash. Oh my God. Can we just like turn off the compiler for this? So this Needs a copy, I think. And this stays the same. Struct enter, RHS struct enter. Why? Wait, what? Why is that? Oh. It's mislabeled, okay. Oh, what? I mean, that makes sense. So we're building an RHS struct enter. I see. So this needs to be the equivalent. I don't see. Do the neofetch thing. Neofetch is rip. Fast fetch is where it's at. Ooh. Yo. Okay, so right. So it's looping over RHS outer fields. What's RHS inner is vec z. Wait, is that it? I guess it is, actually. Did I do it? Do you dual boot? I only use Linux on Metal. I have a Windows virtual machine for Roblox, basically. I think I did it. Okay, let's run the track, run the tests. Fixed, vector, and then cargo, test, release. Okay, so what I want to do is do the dot product here. Oh crap. So instead of doing y dot, I would have yet another macro. Ooh. But so it's constructing. So all I would have to do is like move. Yeah. So field here. Ah, okay. All I would need to do is turn this. I would have to turn this into. Yeah, so I just put this inside the macro. Okay, save. And so I put this inside the. I believe. Put this inside. This is not real. Directly dot product to avoid a copy. So LHS, all this stuff, comma, and then this is going to be wide mul instead of wide dot. Boop, 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 boop. And then wide mul. And then now I locate the dot product macro and just yoink it. Literally. Yeah, so it's going to be the dot product here instead of... Oh, but then I need all that stuff. Okay, so this is... I need all this. Oh. Hold. Hold on, I'm cooking. So left. So this is completely the right-hand side of this. So it's left field dot, and then the right hand side. Or mul. Right hand side is RHS from field static field. For real. So, unmatched brace. Okay. Surely, right? Did I do it? Wow. Wow. What's good? Okay, well, that's everything I couldn't do yesterday. Everything. I just did it all in an hour. Man, a brand new day is a brand new opportunity to write great code. I'm so sharp right after the caffeine hits my bloodstream. Do I literally just need to drink like another coffee? And that's the trick. Okay, well, these are all the same thing. Yeah, merge, and then squash. Yeah. Okay, so I have a macro for matmul, and then oh my god, whew, so sharp, so sharp. I'm just gonna change this comment here. Okay, well, that was very lucid, very flow state. Got everything in there. That's what I wanted to do today, really. What else is going on? So so that's matrix multiplication. That should be like slightly faster than like 10 seconds ago. Because it doesn't like take a transpose vector and then dot product it. It literally just like does the dot product by taking the components and dot product them directly, instead of like reconstructing a new data structure and then using it. Insane. Well, that's macro matrix multiplication. Damn. Wait, this is wide. Why is it named wide mall? This is literally. Matrix dot. Please let me do this. Bruh. Move it like this. No. I think it's like this. And then I take the right side. Yeah. So now I take the right side. And then this is like this. And then now the only difference here is that everything is renamed to dot. Nice. Holy. I'm good at programming and Git. Let's go. Ay. Okay. Does it still? No. Takes so long to build. I believe. Okay, what if I check out this comment? Does this build as well? It does. Nice. Okay. That's what I wanted. Great. Whew. Takes so long to build. It's running like 4,096 macros. What is that? Are you like reading the chat, or are you just telling me that you use editor XYZ? Unprompted. Join stream. I use Vim. Leaves. Reading chat. Okay. Oh, I'll still have to do matrix.vector. Are you using Chatterino? So so deep in the matrix. The matrix. That's what I wanted to do today. No cat, no joke. That's the hardest part. Done. What about, okay, so I need matrix dot vector, and I need vector with length. Or maybe I could just, maybe that's, well, I mean, I got an email to invite me to a meeting where they're talking about how to prepare for the next interview. What? How many, like, oh my god, the bureaucracy. This is the official announcement. Bruh. We are announcing that we're going to make an announcement about the announcement soon. What? I'm already lost. What if I implement the diagonal with the 0? Games where you have to get the most points. Bruh, what? Dude, I just want to play the frickin' racing game. I just want to like drive in a circle for hours and hours. I don't want to work for someone else. Maybe I would be fine if I was writing Rust. Because, like, Rust is, like, so nice. Oh my god. Wow. Oh my gosh. How did I do this? Is that a bus? Are you hearing something in the background? It's a SkyTrain. Skew matrix is like skew matrix. Is there 1, 2, 3? Is there 6 distinct components? A transpose equals negative A. Ah. AJI equals AIJ. So there's 6. I gotta sneeze. 6 distinct components. Woohoo! Okay. Oh. Well. Negative. Well, okay, so the diagonal is... Wait, why am I trying to write a diagonal? Do I need a diagonal? I guess I do for, like, scale... Oh, determinant! Oh. I forgot about determinant. Oh, determinant. Oh. Is there like a link? There we go. So you can do like A times the determinant of this, B times the determinant of that, C times the determinant of that. Oh my god. How do you make it like the least amount of multiplications? Oh my god, I need to put in a macro as well. God, this is gonna take forever to put this library together. If I'm doing like one macro implementation per day. Why is it like that? Okay, I'll be right back. I'm gonna clear my dish. This is a cheese opportunity. Hi. What if I can't even use the library? What if there's some like fundamental thing that stops me? determinant. I've been thinking about matrix multiplication for the past 3 days. And like coming up with the macros to make that work. And I just finished it so fast today. Now I need to switch gears. I definitely need... I guess, what if I write... Okay, so I have transpose. What if I write inverse? Oh, it's another macro. But it's, okay, so it's like wide inverse. You know, like ratio. Why? Man. 5 days ago. I made transpose 5 days ago? Feels like it's existed since the dawn of time. That's like when I learned macros, basically. 5 days ago. Bro. Oh, that's the end of the playlist. That's it. That's all, folks. Let's go Shack Attack. 5,000 songs. What does that mean? Do you mean like in general what's on the screen? Or what I just said that I forgot what I said? When you mean the Tasmanian devil sounds. What? Did I do some autism sounds? Autism noises. Okay, so this doesn't... This is defined for any t. What is this? This is this one. How do you do the... Okay, oh, the inverse... Yeah, so, okay, wait, transpose... It's more fancy. I don't know. The inverse of a non-square matrix... I don't need that though. Okay, I just wanted this. Add Chiget. Oh, it has, okay, well that's awesome that it has a name. Wait, square matrix. Ah, yes. Oh, yeah, oh yeah. It's the transpose of its cofactor matrix. Right. Expansion of determinants. Really? Aye. I think I'm gonna not implement this for arbitrary non-square matrices and just like have a square matrix. I might even just have like a definition for 2D and 3D and just skip 4D. Do I even need 2D? Maybe I only need 3D. IZ. Yeah, this would take forever to design macros for. I only need it for 3x3 matrices. Okay, where is matrix? So, okay, so there's like simple. Is that at the top? Impl matrix. Impl common. Okay. So I'm just gonna yeah. Yeah, I'll just write like. Do I need a macro? I don't need a macro. Nice. Okay. So we got matrix multiplication. I didn't actually need to do it for non-square matrices, but it was. I learned a lot about macros. Okay. Well. So long macros. Oh. Yeah. Yeah. Okay, so so I need some sort of thing like this. My macro mess. Very much a mess. This is unused. Yeah. So we're gonna have full matrix 3x3. Special code. Ooh, special. So what do we got? We need inverse is gonna be in here. Determinant is also gonna be in there. All right, why don't we just go there then? Ay, ay, ay. Ah, I do need a macro. Let's see. 16 divided by 3 is 5. We'll do 4. Okay. Golly, okay. Where's my 8? Common? Mod. Vector? Oh, there it is. Why is it here? Oh, because it's like that. Okay. I'm gonna have one of these for 4. Did I? Screw it. More. Okay, so this one is just nothing, and all it does is call this macro repeatedly. something like that. So I need inverse and determinant. Inverse can be wider. Up to, oh god. Oh wow. Wow. Not having constant generics is so bad. Hello, quaternions. The real what? Who would be? I know you're not real. Why? This is okay. 3x3. What is it? This is determinant. And this is inverse. Afraid. So here's determinant and here's inverse. Oh, what is it? Adjugate? Already coded this. This is a 5-year project. What do you mean? Public function. Oh god. Oh god. Oh my god. Oh my god. Ugh. I need that paste garbage. N. Gosh, okay. Self. And it makes something. What is this? This is a determinant. So this is 3 times n. Whoa, n times 3. Times 3. Disgusting. Oh. Oh. What is this for? The game engine. It's for. It's for this. I am planning to rewrite the physics using a different vector. Oh, nice seg fault. Using a different vector library. The one that I'm writing right now. It's going very poorly because Rust doesn't have const generics. Like, everything would be great if I had const generics. Can't make that. What's my hand running into? Why is this cord in the way? Why not code your own version of Rust? Because it would just be a version of Rust. Like, this project is gonna take a while. Maybe const generics will stabilize by the time I'm finished. Haha, doubt. When is the next Drave client beta release? Beta, but probably. I was hoping to do it by the end of this year. Have like some sort of cool. Something just came off my mouse. I was hoping to have a demo. This booster doesn't work. I was hoping to have a demo with like a few maps. And you can like so minimal demo. What would a minimum viable product demo look like? You would have to be able to click buttons to load a different map. You would need to be able to get a bot and play back the bot. So you need to be able to get a time and then view your time. And that's all I want to go for, is like load maps, save bots, load bots. Which const generics feature do you need in particular? Is there like multiple things? It's the one where you add constants in the generic. Is that not just const generics? Just different things they cannot do. Oh, I made it. This booster doesn't work. And I missed it anyways. These stupid green things. I wrote the matrix multiplication macro, and now I'm giving up on determinants and inverse, and I'm just hard coding it for 3D. I wrote, oops, I reset. Look at this. I wrote 13 nested macros to directly implement matrix multiplication. Why are you using macros? Because it needs to, because I don't have const generics. That's why. Yeah, this is crazy. Yeah, so this was my first implementation. I was like, oh yeah, just so map means like call this function on X, Y, and Z. So I just did the right hand side transpose and then the dot product for each thing, which is like obvious, and then I expanded that into a triple nested macro that's already inside of 10 nested macros. I'm gonna not go that hard for the matrix inverse and determinant. Still cleaner than C macros. Damn. Yeah, so now I'm implementing determinant and the adjugate matrix, which I just learned about. And then I'm gonna try and like avoid doing divisions.
Good stuff.
Yeah. So this is basically it. That's all I need. Am I lying? Well, I don't know much C, so I can't chime in. Okay. How do you do determinant? Okay, I'm just gonna do like self.x-axis wide dot, and then right, need more pasting. Yeah, I guess you do the cross first, so it'd be am I allowed to do that? Is that gonna compiler error? I guess I could just make a macro if it doesn't work. Define private public. Define public private. Wait. Text replacement. This is, yeah, so this is like working with tokens in like a well thought out way, but it ends up as just an entirely new language. Like this is not Rust. This is like Rust 2. Okay, so I'm going to do the dot product and then I'm going to do the cross product. What is it? Is it just XYZ? I forgot. Where are we looking here? Yeah. I'm just gonna look at this as the source. Determinant. Whoa. Cross dot. Proc macros. I did make a proc macro previously. I just wanted like a really basic new type with get and set, where like you would just derive. I called it ID. Where is it? It should be like in here. Oh, here. Something here should have it. Oh, is it? No. There. ID. So that just makes this function. That's it. It has new and get. So new, get. That's it. That's my proc macro, is to have a private field, and it's like it's an ID. Because I had written it like a lot of times. Have you had any issues doing stuff like playing games? I don't play games with anti-cheats, but I have had some issues where, like, usually it works perfectly or it doesn't work at all. STD ops dref. What? Let's see. What is that? Rust dref. A string to behave like a reference to a stir. Yes. So you could have a reference to the value. I don't know. I don't really like the star everywhere. Get. Yeah. The star won't be everywhere. Does it just magically coerce? Wait, in the tarnation is the dot operator. Well, it's okay. How is this used? Contact attributes. It's just like an ID that gets shoved in everywhere. It's just to make IDs type safe. It's like I'm an ID that points to a contact attribute. I'm an ID that points to a model. Immutable access. This is like copy. Model collision attributes ID. So this is the map that's loaded. That's your b hopping in, and then the attributes ID is an indexed into the list of attributes on the map. Just a suggestion. I don't. What I don't understand is how it would look in practice, and like would it just would I be able to go like this? Like it would be like that, right? It would be a dref. The star would go everywhere. box T with T. Never use a dot operator. Yeah, no, there's two methods. New, get. That's it. It's basically just a hashable U32 thing called .dref. This is shorter. It's just a ID that can be stuffed in various structs that is type safe and doesn't let me put the wrong type of ID in. Instead of having like unlabeled U32s everywhere. Trying to be type safe, you know. From and dref. From. Well, I guess from into, huh? Applies consumption. Well, it's copyable. Yeah, it's like it's always U32s. Where did it go? Yeah, so I have all these. I have all of these hash tables with different IDs. This is like the way to do this, right? There's not like a better way that uses directly references when like, because like if I have a map that's partially loaded, there's a chance that an ID points to something that doesn't exist. I feel like IDs is as good as it gets for like a map file with a list of meshes, a list of models. Because like I made the push self algorithm use references, which was great, but it's really self-contained. IDs is the way to go with self-referential structs. I just like imagine some sort of like Rust crate that takes the place of the IDs and like has some sort of lifetime stuff. I don't know. And then you have like unsafe on the inside. It works for you. It definitely does work. It's not a big problem. Which aspect would be unsafe? I don't know. That's just my imagination of like what, like the sort of async pin stuff where like you have this giant self-referential struct and you want to like just kind of do a bunch of stuff with it, and you have references that are not quite references. I don't know. IDs seem to be working good enough, so. Okay, what was I doing? I was trying to write some stupid macros. Matrix 3 by free by free. Stupid. It knows the T it can index. Cool. That sounds like a little bit better, yeah. So what, is that like a phantom data? Yeah, yeah, like it would be nice if I could directly just if I had a vec of T and then I had the key to that vec. But that's like re-implementing vec, right? So like that's easy with hash table, but not so much with vec. The playlist ended. The 5,000 songs playlist. We're on Shack Attack now. Put a wrapper around vec. Well, then you need like. All this type of stuff. You have to just go through and redo everything. So like the idea would be that you could like do vec.get key std vec. No, yeah, I am talking about that std vec. I'm just saying like if you have a new type around Rust vec, then none of the traits and like stuff is usable. All of the excellence vanishes, and you have to like plummet through. Okay, what's going on here? Did I change branches? No. Okay. Where's the code I was writing? Did I lose the code I was writing? Oh, here it is. Hey. Seal and expose what I need.
Really?
Probably, okay, the cross product is probably just in order. Okay, I feel like this is gonna kill me. Unclosed. Oh. Could not find compile error in the crate root. Nice. Right, you have to directly refer to it. Test my OBS alternative? What? Are you writing OBS in Rust? Okay, another macro. Yeah, wee, wee, wee. Um. It makes an ident. I don't know, man. Do you have a paste instead of a paste? Macro, macro. What if I surround it in the braces? Doubt. Doubt. Yeah. So this makes an ident. But I need it to be not const generic. Which is what I'm coining my stupidness as, working around const generic. Oh my god. Okay, I guess I just shim it. Let's do it. Macro, macro. When in doubt, shim it out. Oh, well, I already needed that, so. Yep. Just for that. Oh, okay. So now I need this. No way! I can't calculate the function name! Okay. 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 All is good. All is good. All is good. We just need a worse macro. Alright, here we go. 1 and its double is 2. 2 and its double is 4. 3 and its double is 6. Why calculate it when you can hard code it? I'm gonna bring this down because it's useless anywhere else now. Wow. 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 Okay, what's up? Right. That's correct. I have never implemented cross product. That's another hard-coded business, isn't it? Okay, this is... I was so excited to make a library, and then I needed to use it, and there was no const generics. Now it's just anguish. I have to like, it's anguish. This is horrible. Like I was like, oh, I'm gonna make a nice library. Maybe other people want to use my library. This is not even. This is barely usable by me. I need to constantly tweak this and like add little stupid functions to it. gray. Okay, well that should be determinant, but I need to implement the wide cross. Okay, okay. This doesn't need to be this expanded. It's not a crazy macro. I'll leave it on this. Adjugate matrix. Yahoo. Okay, so it's gonna look mighty similar to this. When you're near. Why did that happen? And adjugate. It's just gonna be a big fat special case. Screw it. I'm gonna move this out. Oh no, never mind. I do need it here actually. Okay, so this is same thing, but it's the adjugate matrix. It's the adjugate matrix. Okay, I'm just gonna steal it from my own code. Self-own. Where is it? It's in here. Ah, it is not. I removed it. Okay, well, let's memory. Oh, it's here. Jeez, okay. Okay, it's here. Yay! Matrix inverse. Let's see it. Oh, cross product. Ooh, look at it. Cross product. Ooh. I can remember cross product. I'm replacing all of this. Inverse times det. So this is actually adjugate. There's a name for it. Oh my god. Could be Jesus. Okay. It was const. That's pretty poggers. What am I doing? No, I can't use const because widemul uses something. Unlucky, unlucky, unlucky. Okay, what am I writing? Adjugate. Where did it go? Oh, it's over here. Okay, so none of that is real. None of that is real. None of that is real. Can I do Control M? Nice. Huge. Okay. Hmm. Where's the, what is the constructor? Oh, I guess I literally just XYZ, huh? Okay, why? Matriarchs. Okay, every single star is replaced with something. Okay, that's like more operations. I think all the brackets in here can be deleted, actually. Okay, and then every star becomes a wide mall. And it's the same wide mall. It's this one. Let's go. Are any of these the same? I don't know. Okay, dot, wide mall, open parenthesis, go, 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 close parenthesis. Okay, so wide cross is actually, oh my, mall. Beautiful. Adjugate matrix. Let's go. Adjugate matrix. Let's go. Adjugate matrix. Let's go. Okay, so inverse is not real. N. Oh. Nice. I can't really say that, can I? Like, can you really call this nice? But that should be the implementation. This is like whip 3x3. So I need, on top of this, I need cross product, and that's it. How basically, oh, I'm doing this. So vectors have special um, cross product. Okay, so that's there, and then we go. I'm just gonna copy this one. Matrix. Ah. So now I do my dumb stuff up here. Wide vector matrix. Vector wide 3. So I can do macro 8, I believe, and then so then it'll be cross product impl vector wide cross, something like that, and then that is like that, and then this is the actual do n expr, and then gross product wide mall. Where is the dot product? Oh, there it is. It's that one. Yeah, 8 by 8. Go. Sure. Oh. Okay. Right. We need LHS, RHS. Give me that. Do it. So it'll probably look like this. Okay, cross LHS, RHS. Okay. Okay. That is not right. So it'd be like, so, yeah. Okay, so let's do it. X is y z minus zy. Y is zx minus xz. Z is xy minus yx. Wow, cross product. Wow. Ooh, cross product. Ooh. Okay, so then left is here, self. And then wide mul goes here. Dot wide mul. And then dot wide mul. Don't know why it's tabbing like that. And then RHS. Like that. There's your cross product. Okay, who Mr. Limited? Mr. Limited. Okay, so we need the paste. Self-parameter is only allowed in associated functions. That is correct. Damn. Okay. Did I do it? Wow. Wow. Okay. Well, that's everything. C is next to X. Wahoo! Macro, macro. Nice. Okay, I'm gonna write some tests. If you do the determinant, if you need like a real matrix to do the determinant. Okay, determinant. Okay, so if you just go like 1, 2, 3, it's not gonna work, right? Determinant 0. So I actually need to go like, oh, this is a 7 actually, and this is 6. Okay. Okay, design some tests. Yep. Test debt. Why? Okay, 1, 2, 3, 4, 5, 7, 5, 6. Is that what I wrote? 9. I don't remember. Interesting. So it's like I swapped those two. Oh, duplicate message in the YouTube chat. Wow. Okay, so basically, we have M. Okay, what's the inverse matrix? Yes. Inverse. So I can get the adjugate matrix like this. Scooby-Dooert. Wait. Oh, that's multiplied by 7, you goon. Is that the same? Would you look at that? Okay, test debt. Okay, haha. Okay, let's do it. Cert equals M debt. Oh! 7. Let's go. And then wide matrix adjugate. What did I do? What did I do up here? Okay, I did that. Okay, cool. Okay, yeah. Okay, so adjugate. There it is, folks. Ah, jeez. Ah. True. This is Scoobert Doobert. This is a little bit different. Um, this is 396. I think. Is that true? So it's. Oh, it was just totally wrong. Neat. Scoobert Doobert. Okay. Now we run the tests. Run the track. Great. Wow, it takes so long to compile. Oh my god. Oh my god, it takes so long to compile. Oh my god. Good thing it's a crate and it only has to build once. And then I have incremental. This is so awful. Should I meh, adjugate is fine. I mean, well, I wouldn't want to write INV, so we'll do adjugate. Why is det okay, but adjugate isn't? Adjugate is like on the line. Incredible. Incredible. Absolutely credible. Implemented and tested. Night birds. Bruh. 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 Now I have to implement it. That was a huge rewrite. Where was this? September 2nd. And it is currently September 4th. It only took 2 days? I guess I was like doing const generics and stuff. Yeah, with const generics. I could just have one matrix type, one vector type. One implementation for everything. Bruh. I prefer matrices with axes to raw. I think the glam implementation is good. Oh, if I had a const generic, you couldn't access the axes. I see. What if it was like a type union? Transmute. Unlucky. This is not it. Mm. Hmm. If I want named axes, I can't. Have X. I feel like that's not something that's doable to like translate. Like if you had a matrix M and is represented as an array of arrays, I guess I'll like write a little test and then ask the chat GPT. Did I save this? Yes. Okay. I'm gonna make a thing. Okay, so we have struct. Tuple structs and accessor methods. Oh, so it's just gonna do that. But then like you have to. Yeah. What if I had the external goober be like this, but then the implementations internally used like the union and like transmute? That could be interesting. I didn't think of it that way. So you make a thing, and then it goes like, oh, this is actually an array. This is actually using questionnaire. So I would have. Oh yeah. Okay. Well, the problem is. Yeah. So the whole reason was that I wanted to have like constant generic methods on the struct on the object. But if it has to convert it to a different object, then like they're not on the same thing. If I implement it for the union, does it implement it for the thing? Okay, so I don't know. Let's see. Okay, struct. It doesn't, does it? How do you use arrays? Map. Like, iter. Oh, zip? Is the memory layout the same? Surely, right? Surely. I guess it's like not guaranteed strongly in Rust, but it would probably be. Oh. Yeah. Is this into iterator? Yeah. Map. Can I straight map this into like SDD ops mall? Some. Oh, mall. Get out of here. Two tuple. Oh, true. Oh, that's a scam. Okay. Unlucky. True. Cope. Okay. They're reconstructed. Fields in this struct. Method and implementation. Never used. Oh, it's just saying it's never used. Okay. Devious. ChatGPT's like, ah, yes, you are devious. Haha, my good sir. Yeah. XD. So the problem is you have to make it, and then you don't get the fields directly. So it's a scam still. And then like it sucks. Devious. Safely. Implement traits like deref. Magic vector 3. Struct. A reference to a temporary rate. You can't do that. Because it's dropped at the end of the scope. Magic vector 3. No. You cannot. There's no way. Deref. So it'd be like, okay, see, it would be like, oh yeah, so you would make a magic vector 3, but then deref. So you would go impl deref for magic, and then give me the stuff. Sure. Yeah. Okay. Target equals. No. Mood value. Oh, this doesn't. Okay, well, that's fine. Okay, so I doubt it'll work. Doubt. No. You can do that? It's possible. Oh my god. Wow! Wow! Wow. Wow. So you can have an array-backed vector with constant generics and be able to access named fields. Wow. So you could say, instead of R vector 3, you could say like, oh, this is actually a constant generic. So it'd be like, what is this? R. And then, so this would be an R3. This is R const n usize with spelling usize n. And then all the stuff is implemented on this. But this, yeah, it doesn't quite work. This is amazing that you can do this. How do I, like, what do I call this? So yeah, so, what was I trying to do? Okay, so I was thinking like, matrix dot, if it's matrix 3 with named fields, and you want to like do it with like non-square matrices, the names conflict unless you use const generics. But then if you're using a union wrapper type, it doesn't have the functions on it. And you can only have a yeah, you can only have a single implementation of deref here. Unless you can. Yeah, no, it's conflicting implementations. That's what I thought. Does deref has a generic? No. Okay. Still super, super, super cool. Incredible. This guy wants iter. Wait, that's... You can just do that? Okay. Hmm. What happens if I run it? Wait. Oh, okay. Okay. Amazing. Amazing. This is so cool. So I could also do this. And it'd be the same, right? Oh. Cool. That's cool. So this piece would have the constant generic implementations on it. Yeah. So like, if you want to do matrix 3 by 4 times matrix 4 by 2, be conflicting implementations, because like you can have vector 2, 3, 4 on the inside. So okay, I'll explain the problem. If you have matrix 3 of vec 2, and that implements dot something, and then you have matrix 3 of vec 3 that also has dot, well, now you have conflicting implementations, because you've already implemented dot for matrix, and then you want to do it again. It's the same function name. So that's why I have all this paste code everywhere. That's just horrible garbage. That's like making different function names for each implementation. But if there was constant generics, and I could just say, this is a matrix 3 of a vec 2. Then that's only one implementation on this. But then you can't do like m.x axis. like you could, using this, you could do like matrix dot x column. You could like have some magic structure that has the same memory layout, and it's got like x pad pad y pad pad z pad pad, and then no, that doesn't quite work actually. Never mind. It doesn't quite work. Not quite. You would have to transform the memory layout thing, and you're copying at that point, and it's not quite. Oh wow 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 wow. Hmm. True. Oh, I see. So this is generic across any size of array, but this is special for vector 3. What I was imagining was like, what if you had an array backed vector that you can access the components simply like this, named. But also had generic methods that are not, yeah. That are based on const generics across the dimensions. So it works fine with vector because, like, oh yeah, vect, like, oh yeah, it's fine. But then when you try to do matrix, but I guess that's, does the story change with const generics? Maybe. This is really cool. like it. This is a cool demo. Is there a mutable equivalent? I guess it's kind of... Oh, it is! Hot diggity damn. Baroque. Okay. Okay. Oh. How do you... Ah. So then can you do... v dot x equals 5? No way. Oh my god. Wow. This is awesome. What the hell? Named access to array fields for free. And mutable access. Zero cost abstractions. So it would be totally fine if Okay. If you don't put vectors in, it's fine. So if the union for the matrix is just array 9, and then and then there's no multiple implementations. Oh. Mm. Yeah, so it basically just sidesteps the issue entirely, though. But but you can have named access. So if you use pure matrices that don't have vectors, you can still have field access named field access, even though hi, I am exploring a concept in Rust. Oh, I guess the stream title is still accurate. My library is elsewhere. I'm like doing it dumb to like make it work. But I'm imagining, what if I didn't have to make it dumb to make it work? What if I could make it nice? Basically, it's the exact same thing again, except it's two-dimensional. Wrong. Uh-oh. Okay, well, can I do XYZ here? I need... No? Maybe I can. Let's see. The inner, this is the outer, this YZ. And it turns into... No. Some X Z. And then you just for loop. Map. I can look at the old implementation I had. Macro map mall. So this is like this. Ay, ay, ay. Bruh. Can we like have something that doesn't suck here? Transpose map. So it's the RHS transpose. Wait, what the hell? You goon. Okay. What? It's X. For each. I forgot. For each. I just wrote this. Transpose axis. Okay, so for each transpose axis, what does that mean? That means the for loop across hee hee ha ha x for y. We need a Z. it's is it some? Other, okay, let's try, okay, other, oh, I see. Oh. So that's over Y. But we want to end up with a Z. But it's not a transpose axis. It's something else. This is X. Oh, what? Did I do it backwards? There's Y copies of X. Oh, I had columns before. Oh, what's that? Was that, did I do that wrong? Confused. Very confusion. PR map dot. Okay, so that's like. Hmm. The outer is Y, yeah. Mm. Oh. Oh. I just gotta write this. Just gotta write the const sounds xyz array 2d yz x yz map apps because iter map tracks. Oh my god! Why is it so hard? Array of size y. Yes, and then this is array of size x. Confused. Wait, what? YZ? Why does it say YX? What incarnation? YZ? YX. Oh. I see. So this is... So the number of iterations of this is... Y. And then this... confused. Okay, whatever. I'll just like... Huh? I can't think. It's so hard to think. Why is it so hard to think? Oh, haul up. Oh, haul up. Oh, haul up. This is like this. Okay, how about I just transpose it so that I can write this? I don't know. Okay, did I get it right? Jesus, okay. Array YZ. 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 I got it backwards. Oh. F32. Oh. Oh. Nor. Okay. Holy, okay. Screw it. Bro. So, unused. Okay. Well. Okay. Yeah. That's it, right? So then you just dot. So you can do like a from. Okay. Yeah, I'll do that for the other one as well. This is beyond science. Okay, let's do a triple. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. What? Where's my tests? Test. Dot. It avoids. No, it doesn't. Oh. Oh. Hmm. Okay, we're back to the problem at hand. Well, for this thought exercise, where this is a matrix 3 by 3. But if it's like, oh, I'm any size, like in it, you want to be able to implement dot. Oh my. Dot with the generic array implementation. But also be able to have different size matrices that you can just do dot, and you can just dot with any other size. Yeah. I think you can only. I mean, you could transmute it back and forth. It's not convenient. It's not convenient. Deref mute is insane. matrix multiplication. Well, dot. It's everything, right? Inner product, I guess. So we have like. You can dot this. And like that's dot product. And then, well, it's inner product. But then you can also do this. And that is dot as well. Maybe I should just have it something else. Is this a different thing than that? Like, I can't really do that in Rust, I don't think. Have them be the same thing. Unless it's a trait, which I established would not work. And is the focus of a giant rewrite. And then, of course, you've also got this, which is the dot product. The usual matrix multiplication. Yeah. Like, there's 3 different things, and they're all just dot. Let's see. What is the difference between dot product and inner product? More general classes. So dot product is just vectors only. And then when you do the matrix product, that's the inner product. Transpose. Is there no difference? The bi-additive form. The bi-additive form. Vector. Infinite dimensional. Oh, yes, of course, of course. YouTube. Generalizations of the dot product. Where does matrices come into this? What are you trying to do? Are you want to generalize matrices? Not especially, but a lot of stuff seems to get elegant. Like, I can't use const generics, so I have to have like named functions so that they don't conflict. So it like sucks. It sucks. Like, all of this is just const generics. If I could just remove it all. const generics. So I'm exploring this interesting interesting idea I had where, what if you have an array-backed vector with named field access? So what that means is, so you have an array, size n, and you have a vector 3. And what if I wanted to have it, like those are the same memory, right? So if I do a union, and then I implement things on the union, and then I go down here and I do magic vector 3 from an array. I don't know anything about Rust. Oh, yeah, this is all Rust. Then I can do, if I implement deref mute, then I can access a named field of the array and change it to a different value. For free. While also having the like const generic, but not really. So for arrays with constant size, that's when I say const generics, that's what I'm talking about. You can implement this like dot product for any size array once, right? You don't need to say, oh, well, if it's size 3, well, it's like this. If you do size 4, it's like this. There's this one function that does it for everything. And then I was a bit lazy here. So here's an array 2D. If you do the dot product of array 2D, I just do the transpose, and then I do whatever this is to do the inner product of two matrices. That's like a non-square matrix multiplied by another non-square matrix is a third non-square matrix. And that's like general everything. But then I want to be able to go like, oh, what's the x-axis of this matrix? And so if I have a union, and this has a bunch of like generic implementations of functions, and this has very nice named field access. What if I put those together and I have something that does both? Seems like it's a cool idea, but it doesn't quite work because I need to wrap the functions in order for it to work here, or I would need to like constantly transmute between the two data types, which like that has to appear in your code. Rust default makes things immutable. Yes. You're hacking it to make it be immutable. No. Yeah, that's an entire Rust discussion. Immutable by default is pretty powerful because like there's two ways it can go wrong. It can go wrong because you were making an algorithm and you're like, oh, I meant to make that mutable. Well, that's an important distinction of like you're confirming that that's how you meant to do it. And then also there is oh, I didn't mean to mutate that value. And then that's another confirmation of what you intended. And you erase or you fix the thing that you tried to mutate, but you didn't intend to mutate. So in both failure cases, you are prevented from making a mistake. And so you only get good things from immutable by default and needing to specify that things are mutable. Every single way it fails prevents you from making a mistake, which is amazing. Very good. Dot. Um. Oh. Um. Uh. Right. Does my code compile? Okay, let's try it. What happens? Okay, let's see. Let's see. Okay, if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, and then we do matrix power 2, we get 30, which is what this said. It's so interesting that you can have an array-backed matrix and like mutable fields. Well, I mean, it literally is mutable fields, but it has this like const-generic underpinning. Wow, 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 wow. I really like this. Really like this. It wouldn't always be nice. Well, actually, no. It would always be nice. Actually, it would always be nice. Wow. 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 So you can like do anything you want like this. Wow. 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 So it coerces it to deref mute. That's insane. It's like it goes from wow, 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 wow. It's so close. Yeah, because you can't have one function name to multiply with other magic matrix. Unless, what if it's a trait? What if you use a trait bound on this, and then you use const generics on this, and then you say, yes, this implements. What if it's like that? Trait bound. Well, can you know? Can you know? I don't know. This is really cool. Okay, so I was thinking, what if there was a trait? Would it could I could I can I say I don't know. Let's try trait inner okay. Ooh. Ooh. Okay, and then it goes like implement inner for array. Hee-hoo, hoo-hoo, haha. Alright, just equals self. Yeah. Array n. Yeah. Type output equals F32. Function inner self. Can we like have stuff? Niceties. Yay. Self dot RHS. So if that's like that, so vector 3 is fine. And then this one, it's gonna be something else. Gabba gabba ooh ah. Something else by a lot. So I can't put generics there. So I guess I actually need XYZ on this trait. Impl. So it goes like, oh, actually RHS is this. Oh, yeah. And then this is like this. And then output equals this. And then that is not true. Other is this. Can you see RHS? No. And then that's it. Okay. Associated type, like this. On the inside, it's a T. I don't know. Array 2D. Yeah, it just isn't coming together. But like the my idea was like this would be like a trait impl. And it would like use the trait bounds of this to go like, oh yeah, I can do that. But this isn't generic. So how do I make it generic? Okay, so what if but only vector 3 exists? Yeah, it doesn't really work because like each one is a different type. Like it's generic when you go back, but okay, what if I skip the magic and directly implement deref? I think that's it, actually. I think that's how you do it. That fixes everything. I think that fixes everything. Yeah, because then you have the like true type. I think that fixes it. I think that works. Hold. Okay. Okay. It's more or less a restart. So basically, there's no unions at all. At all. No union at all. And basically, instead of you doing, yeah, no, let's do this. Okay. Yeah. It's array 3. Implement deref. Yeah. So each one would have its own deref target. Ooh, oh, except it's. Oh. But you can't, right? Maybe you can. Maybe you can. Um. Cause like, what is the lifetime of this? Okay, let's see. Magic vector 3 array. No, because I don't have it. I can't deref and move. Oh, what am I doing? Yeah, well, I mean, I could do this, but then it's still temporary value created here because I moved it. Construct union as reference. Can I? Let's see. Rest construct union from reference. Okay, whatever. How can I construct a union from a reference? Let's see if it understood what I meant. Sick? Sick? Without copying. Transmute. Well, this is still copying, right? I wanna... Yeah, I think the ownership rules are sussy. So what? I just transmute the raw pointer? I guess that's how you do it, huh? Rust transmute raw pointer. Dude, this is awesome. What is this? Transmute. Yeah. Let's try it. Let's try it. Okay, this says... Okay, screw it. Yoink. Okay. Unsafe. Giga unsafe. Okay, so... SCD mem transmute pointer. How do you get that? Const. Okay, const. So it would be... Can I go like that? Does that work? I mean, it may as well just transmute directly at this point, right? Oh, unsafe, unsafe. Nice, nice, nice. Ooh, that works. Okay, how can I... Source destination. Demon. So like... Yeah, it needs to know the like in-between type, I guess. Well, why even have the union at this point? Like, literally just transmute directly into it. Yeah. Easy. Okay, easy clap. And then this is the exact same thing, interestingly. Pog. Okay. So apparently... Alright, gimme. Yeah, so now this is the const and inner array. Okay, so const and array n. Impl const and array n. For array n. Yeah. This is wild. Okay, what about... Okay, so the So it falls apart for matrices, cause yeah, cause it could deref to multiple different things. No. No, it's a separate one for each type. This is it. This is it. This is it. You have a const generic backing. This is it. This is it. Wow. Okay, so what about this? Okay, which one is X, which one is Y? YX. Why don't I just do self instead of what else is doing? Or value. Self. That's wrong. Game. 3-3. Oh. Okay, so this is a matrix of vectors. So this is actually this can be T. And then we can do T. And then no. Have you lost your sanity? A little bit. Well, there's a little bit of drain, you know. So array 2D, 3x3 is a matrix 3 of vector 3. And then literally, it's literally just this. Literally. See? And then this. It's array 2D here. And this is array. Dref. Ha! Okay. Does it run? Does it work? Did I do it? Wow. Wow. What a cool project. Wow. So the array directly has const generic dot products, and then there's specialized deref implementations for specific array sizes. So, 4x3? Well, that's a matrix 4x3. And then you can have specifically named. Wow! Wow. This is next level. I think this could actually be like library material. Cause like you can go insane with const generics and make things like arbitrary matrix multiplication stuff, and then you just like, the x-axis as well. You can have both. This is it. And that was the key. Deref. You just do dot x equals. You can just do dot x. Dot x. So, so now what happens when you try to do it between 2D and 1D? So if you do the inner product, this is great. Okay, I don't need the trait. I'm gonna drop the trait. Um, question, what's so good about Rust other than its speed and memory safety? What I like about Rust, some of the things that I like about Rust is that it's very carefully designed and carefully thought through, and everything I do seems to have a dedicated function for the like specific domain that I'm trying to make my code for, that is like safe, fast, and like the best possible implementation that like just does exactly what I wanted to do. And someone has already thought it through and has already made this function. That's in the standard library. It's all like very carefully put together. Rust is like less expressive than because of the borrow checker, but when you bind yourself to those rules that the borrow checker wants, you can make really powerful statements about your program, such as it is memory safe. And you can also say that no two things will try to edit the same value at the same time, because the borrow checker prevents you from holding two mutable references to the same value at the same time. At compile time, it statically analyzes the program and prevents you from doing this. And that is useful for multi-threading. So you can like write insane multi-threading code, and if it compiles, you can pretty much be sure that it works. If it compiles, it runs for the most part, unless you have like a major design flaw. So like the distance between a valid Rust program and another valid Rust program that you didn't intend to write is much farther than other languages. So you can like write valid syntax in a different language, but like make a mistake, and it's like a subtle issue, right? But with Rust, the restrictions and rules make that much farther away. So you have to make like a very large design flaw to have a valid program that's not what you intended. So like it really just guides you to exactly what you intended all the time. You'll go to try to make something, and then you'll be like, oh, that won't work with the borrow checker. Well, if I did it like this, and then it turns out that's a better way to do it. So it's always like guiding you to the valid program. And there's this like magic, really, that comes with writing Rust. There's definitely a lot of syntax, so it's a lot to learn. I recommend rustlings as the programming exercises as a way to learn. That's how I really got started with Rust. Okay. And of course, because it's a compiled language, I have a working program here, and because like the distance between working programs is so far, if I start making my intended change like this, now the compiler will point out everything wrong. Okay, well this, I don't want this, and I don't want this. All right, we're back to a working program, and it guided me through. That's true with like C++ and stuff for the most part. But like if you start with a working program, and you have an intended change, the compiler will like guide you through how to change your program to make your intended change, and then once it compiles again, it's working. Amazing. Ugh. So could I do... Can I chain this? So can I go... Does it fall apart if I do x-axis dot x equals 0.5? No. Wow. The chaining works. So it gets a mutable reference, mutates it. Wow. That's such a nice interface to an array. -2, 0.5. Wow. This is hot. This is hot. This is super hot fire. I'm not sure about array 2D, or if it would be better to just have it as an array of arrays. This is so carefully crafted. I didn't even know about this feature, and it's like, how did I live without this? I guess it's like specific to this problem domain, and like once again, it's just so applicable. Is there a default implementation? Incredible. I wonder if we can have this be a private type with public fields. So you're never allowed to know the type exists outside of the crate, but you can access the fields and use the fields to manipulate the value. God, this just makes me want to start over and just like do the whole thing again. Because like this solves everything. Well, except for constant generics. You need constant generics. So I wanted these things because I like accessing the fields by name. But like arrays are like crazy better. So if I can have the best of both, let's go. This is like beyond science. This feels like scripting language stuff, except it's free. Zero cost abstractions. All happens at compile time. Golly. I guess you lose some const. Well, I guess if you have const traits, there's another Rust feature upcoming. But are const traits opportunistic? Like, does it require the function to be const, or can you just say, oh, this is const? And then it's like, ah, yes, this is const. It's gotta be like that. You can't just demand that it's const. Well, I guess you can. Yeah, it would have to be both. You have to allow the trait to demand the const implementation, but then also allow a constant implementation on a non-const function and have all the benefits. Well, no, that's true. You could. Okay, that's probably why const traits aren't stabilized. Easy. I should publish stuff to GitHub. How do I make a repository? Where'd he go? Yeah. I'm sharing this with my friend. I'm gonna actually edit the code to say that. Neat. Well, that was. I didn't expect to like actually figure that out completely. I thought that it was a dead end, but was interesting. I think I need to think about things more. Like, is this right for stuff like glam as well? So glam. Is Rust library I'm using for stuff. But like, what if it was generic, but it still was good? Oh, and you give. Oh my god. You can build out everything. Like, BVEC is just a vector of bools. Generic. And then like BVEC 3 is a size 3 array of bools. Which like that's like, yeah, ooh, wow. It's not that great by itself, and then you have like the wacky type signature. But then when you have const generic, fixed size, so it's stack allocated, and you can use the same function, the same algorithm for everything. And you get the convenient named field access like this. Like, is there an example? Come on. There's no examples? Bruh. Where do it be at? Vec3. So, okay, where's the stupid type? Vec3. There it is. So, like, look. This is, they got their stuff. It's like, yes, XYZ. Splat. SIMD. Oh, Spurvy. What in the tarnation? Okay. So instead of having like all this code separate for everything, it's all just the same code. Cool. And then like you have like everything on every type. One implementation. As much as you can. You see a map? Ugh, it's written out. Crazy. But, I mean, it's, yeah, no, there is benefit to this, because, like, this is so easy to read. Splat, oh, it just puts it in XYZ. Whereas if it's, like, const generics, and it's, like, what does this mean? It's very opaque library. So there is benefit to being less opaque. Select mask. What the hell? Oh, true false. Okay, cool. Nice. I'm in shock. This is what is that? Core iter product sum. What in the tarnation? Oh, I see. Interesting. Okay. Iter product. Right. Huh. Is that a trait? Yeah, it's a trait. Interesting. I. Oh. The iterator's generic. Oh, I didn't know that's how iterators worked. That's very clever because that means that it's like this, and you can just have the item itself implement the trait, and then it works for any iterator that uses that item. That's very clever. I'm learning things by just reading the source code. It would be unreadable if I use const generics. I wonder if it would do loop unrolling. Would it be as good as writing the code? Guess I could test it. Look at how tiny it is. Erg. Okay. How does the dot product work? When you do the dot product, does it cause pain and suffering? Let's see. All right. So yeah. Okay. So if we do this, oh, wait. It did it. Oh my god. Is there any loops? I think it did the loop unrolling. Okay, what if we don't... What if I don't print? Red! Oh my god. Okay, let's put this here and then go like this. Okay, so it fully did const for that. Okay. What the? It. All of this went away. Oh my god. Really? It saw straight through from here to here, through this, through this, through this, through this, through all of this. And it's like, oh, that's a constant. Here you go. It's 3. Or whatever it is. Huh. $38. It's 38. That was that's a little bit crazier than I thought. Okay, how would I do this? Okay, so I go like public function dot 3 takes A is a array 3, B is an array 3, and then we return an F32, and it is A dot B. If I do that, do we get an unrolled loop? Yes, we do. Merp, 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 merp. Ret. There's no jump that I can see there. This is under the camera. Excellent. Excellent. So I can have this type stuff and it'll just loop unroll. Orps. Orp. Add 85. Wow. Wow. Well, let's see. Okay, what about dot 3 vector, whatever. It takes a vector 3 and a vector 3. ID? No. And then we do a dot x times b dot x plus a dot y times b dot y plus a dot z times b dot z. Ha! It's the same function? No way. Oh, it's not. Is it public? Wait, what? Oops. Where's the function? What? Oh, it does return the... Okay, I see. Raiders from Raymarch. Okay, dude, look at this. Look at this. Look at how cool this is. Cats. Okay. I I took what you said to heart about deref, and I iterated and thought carefully, and I came up with an array-backed fixed size vector that is accessible via named fields. So look at this. Look at this. So array new, right? Okay, what's that? It just takes an array and it makes it in itself. Array is just an array. It's a type wrapper. Unity and C#? Not quite. Right. Okay, so an array is an array. Okay, we have V as the array. So I have this like const generic function that does the dot product, whatever. But look, I can go vector.x times equals 5. So I can say, take the x component, multiply it by 5, and write that back in. And then I can also just access it like it's a named vector components. So it just converts array to vector, but only for size 3 when you dereference it. I was shocked when you could do this. I thought you would need to like call a function or something. Unsafe mem transmute. Okay, like that's not a problem. They're the same size. They're the same size. It's transmuting the pointer to say, oh, actually, this doesn't point to an array. This points to a vector, and the memory looks the exact same. So it just interprets it differently. I think this is only valid in RepRC. How big of a restriction is that? Because like if I want to have like any array of thing and then like have this like const generic array of fixed size, so probably what happens is it just so happens that the memory layout complains. You can try and run this in Miri and see if it complains. Probably like okay, so if you had like other types in here with like weird alignment, and then like array was like weird, does that even make sense? Because it's just the same thing repeated, and this is the same thing repeated. Wouldn't that not ever change the memory layout? Wouldn't that be like, does it ever like combine things over onto them each other? Like if you have bool, if you have an array of bools, does it like stuff them into like 8 per byte or something? I feel like it doesn't, but I don't know. So it can reorder fields. Yeah, but why would it do that in this case? I had a union before. I was like, okay, cool. What if I had a union of array and vector, and then I implemented stuff on the union, and that's like, I couldn't quite sneak. What's the word for like taking things from one country to another illegally? I couldn't quite get these methods out the const generic migrate. It's like suffrage, smuggle. I couldn't smuggle the const generic functions out of the array and then make it usable on the magic vector. But if I just directly implement the deref onto the array, then you could use const generics for like matrix multiplication, dot products, and everything, and like it like loop unrolls everything. You have one implementation for all your stuff, and you can have one type for everything that has like all the implementations on it, and you can have named access to the fields like this. I think I have to rewrite everything again. Now do swizzles. Yeah, you couldn't do that with the same syntax as like GLSL, because like you only get these specific named elements. You could have a function. Usually you could just have a function. So swizzles are cursed. Yeah. Why are they? How do they get so hard? It seems like, oh, you're just swapping it. Like, why is that so hard to implement? X equals. Which one? Pick one. Pick one or the other, not both. Well, I guess that's where. Well, no. I guess you just use a macro, huh? That would be the Rust way, wouldn't it? Would be with a macro. You have a swizzle macro, and then it would just compile error in that case. I could do all this fluently in C++ 15 years ago. But it wasn't rusty. Objects of type T are valid. Too dumb to write a game in C++, it doesn't crash. That's basically why I learned Rust, is like I would just be writing memory leaks. I would be writing remote code execution, ACE, everything. I would just make the most vulnerable game ever. So it's like, okay, if I write it in Rust, that doesn't happen. So I came for the safety, and I stayed for the like carefully thought through language. Ray March heresies. Sharing structs. Stayed for the transmute. Well, I'm quite new to pointer arithmetic, so like this is like mind blowing when I figure this out. I had look at what I had written before. So I was like, oh well, you take it from this. Oh, did I ever leave that in there? No, I still had that on that thing. Skip unions. Oh, I never committed it. Well, I had like so magic vector 3 was the union type. So it was like union magic. Oh, this is matrix. Let's go up to the vector. Union magic vector 3. So I had a union type of array is an array of size 3, and then the named fields is a vector 3. Vector 3. And then for this, I had let magic type this reference to magic equals transmute self, and I was like, return a reference to magic dot named, and I had this written, and I was like, that's like the exact same thing but done twice. And then mind brand new to pointers. I figured it out. You can just directly do it. Directly transmute. Goodbye. Oh, I'm so excited about this this little idea, because the main reason that I didn't use arrays was because I wanted named fields. You're basically an alchemist now. All that transmuting. Unsafe. Transmute is one of the most powerful foot guns. Yeah, I was looking at it for enums as well, trying to like figure out how to turn, how to like get the discriminant. Why isn't there just like a discriminant thing? Likely UB. Reper-C. Bruh. But it's named field access. Runtime asserts before transmuting. Well, it's supposed to be... If you do that, that'll probably make the code way bigger, wouldn't it? Instead of like... Why is this function not showing up? Is it because I have main? What is going on here? Why does this one show up but that one doesn't? Like if I go like this. It's like, oh yeah, that's your function. Where's the other function? Huh? Hint black box. Okay, well, let's try that. What happens? Compilation failed. You have to wrap it. Oh, like, I see. But then but like I want it to optimize the function. Okay, so probably I want on the call site, yeah. I don't know. Like, why is it just why? Just don't do it. Don't do it. I give up. I don't know how to see the assembly. It's like this one is like so small that it's probably pretty close. And I just wanted to check to see if there was any loop unrolling, and it went way harder than I thought. Pretty cool. Ugh. So if I had Represy on the stuff, everything inside would have to be Represy, but I'd be putting like bools and ints in there. Repr Rust. Let's do this. First, all types have an alignment. Really? I guess that makes sense. So like, this is like, oh, if you have these like going like this, it can like move it around and do this. But if they're all the same size, why would it move anything? Rust doesn't guarantee that two instances may have this data laid out in the same way. Or are you arguing about C++? Right. Right, I see. Okay, so this is like... Are you allowed to like Represy for T? If I have a vec of T, is that allowed? I mean, it's gonna cry about the rest of everything, but I guess I can literally do like this, F32. Ooh, is it gonna do that? F32. Well, that was easy. So I would have to say this is Represy, and then... Oh, it stopped complaining about everything. Haha. So I still get the same stuff. Realistically, this shouldn't be a problem because I'm only gonna put like, well, oh, what about Benum? What even is array? Benum. Okay, well, what's going on there? Get Benum. Benum. Aha. This is the really wide integer type I'm using. Actually, the maintainer merged one of my pull requests, which was unexpected. They're like, oh, digits mute? Go for it. My other pull request was not written properly, and I knew it, but I didn't really expect them to merge it. So I am now a contributor to this crate. Let's go. Do as I say, not as I do. It's hypocritical. So I'm looking for the definition. Can we just do b int mod impl? Is there another one down here? B int. It's all macroed up. This is what I mean with opaqueness. Okay. I was here. We're gonna go to the top of the macro. Struct. Digits. Repr transparent. What does that mean? Oops. Oh. Only be used on a struct or single variant enum that has a single non-zero size field. Ooh. The effect is that the layout of the whole thing is guaranteed to be the same as the one field. Okay. Okay, so it's like you just see inside. Okay. Okay. So that's like to like use on new types specifically, basically. Okay. Bargaining stage. How's it hanging? I made something cool. Okay, so you can't use transparent here because it's only allowed to be one field. Well, let's see. No. Okay, what if I do something strange? What if I say, oh, this is what's a weird type? There isn't really any weird types. Okay, so what if I go like, oh, this is a struct weird, and then it's got A is a U8, B is a U16, C is a U8, and then say, this is actually a vector 3 of weird. Weird doesn't format display. Okay, probably there's more issues than that. Weird. Doesn't implement display. That's all it. Cannot assign .x .a equals 5. God, that's so powerful. Why is this? Oh, IZ. Well, we can just ignore it for now. All right, what happens? UB. So why does it not? So does this restriction apply to this? I don't know. Oh, I was just Tommy, look. This is cool. So arrays are kind of like what the data inside a like linear algebra vector are, right? So like a vector 3 is 3 elements. Vector 4 is 4 elements. Like, why don't you have a generic sized array? That's an array instead of vector fixed size. But then you can't do like vector 3.x and stuff like that. But what I came up with here is a way to be able to do that for free, zero cost abstractions. So you have this like array, and you implement all your like linear algebra on that with like const generics and like arbitrary non-square matrices multiplication and stuff onto array 2D, and that's all well and good. And you have the like single implementation across different sizes, and it's fantastic. But then you go to set the x component, and it doesn't work. But with this, you can do it, because what it does is it goes, oh, you're trying to dereference the array, and then it's got a deref trait here, and it says, well, when you dereference the array of size 3 only, it returns a vector 3, this other type, and then that has the x field on it, and it has the same layout in memory. So it goes like it takes a reference to the array and says, no, that isn't a reference to an array, that's a reference to a vector 3, but it looks the same in memory. So then you can like treat it as a vector 3 when you modify the component stuff. Like I can also do modifying stuff. I can like multiply assign, and like other cool things. And then you could just access it. You don't need like a function call. I thought you would need like a function call like this. Like my other I guess that's what I needed for my other thing is deref. Yeah, deref is crazy. Ugh. What led you onto the path of Rust? I'll be honest, I was like into the hype videos on YouTube from the beginning. I basically knew I was gonna be a Rust man. It's gonna be a Rust hype man. Rust let's see, what is it? The Rust why did I say Rusk? The Rust Evangelism Task Force. I'd be part of the Rust Evangelism Task Force. So it was only a matter of time, and I was like, all right, I want to make a game. I'm gonna learn Rust. And I was right. Rust Evangelism Task Force. Deref is totally not inheritance. It's very, very, very careful inheritance. Very, very, very careful. You can only do it very carefully. Model you should put in your game. Is it object format? I have limited model decoders. Oh, is it Rust? Various 3D. This is your GitHub. Blend. It's a Blender? Wow. Wow. Very nice. I think there needs to be a Rust surf map or bhop map. I'm gonna go say that in the map making channel on the bhop Discord. Let's see. Oh my god. Is it gonna embed? It is gonna embed, but I have that ugly link. Look at this link. What a link. Gosh. Okay, so maybe this is fine. If I say rep_c to get rid of the undefined behavior, how do I apply that to this? Ooh, ooh. Oh, I already macroed everything. Ah. Yeah, that's basically a fresh start. Still don't have const generics. So that gets rid of this part here, the 3x3 matrix. But this you need const generics for. Nested from implementation. I had a thing where it had conflicting implementations. I hate this. _1_1. Bruh. Generic vector A from vector B. That's probably due to the conflicting implementations. Yeah, because like, what if A and B are the same? Can you just extend it? So like, what if you did where A from B? But I mean, I guess that would still conflict with other. Other from. Trait bounds. Oh, my nasty. Okay, so I can still have these. Okay, let me show what I like about this. So vector, I like that I can go like this, and I can say, oh, well, vector of bool. Well, I have these methods all in any when it's a vector of bool, or like less than. So if I have a t inside that implements ord, then I can say vector is less than vector, and it turns into a vector of bool. I think that's super cool. And then it's still the same like outside type, and it still has all these methods implemented on it and stuff. So you don't need an entirely separate type that's like a bool vector. It's a vector generic bool. I think that's cool. So then all the inside implementation stuff would be with arrays instead of macros. Oh my god, this just the entire library rewritten, but like it would get rid of the 4096 13 deep nested macro. A macro inside of a macro inside of a 13 implemented by hand. Is there a better way? Does it just come inferred from this? Really? I just didn't know. Does it does it know to do that? Implemented the ORD trait? No. It's just like mapping less than onto a vector, basically. Doesn't really know Rust. I mean, you've taught me some stuff, so we can not know Rust together. I love this. This thing on Glam is really cool. Gosh. I've been working on this for like a month now, and I want to rewrite the whole thing! Oh. Raymarch said deref, and I went, I like that. V2. Unstable traits. Yeah, I gotta stay away from unstable Rust. My game would like collect unstable features. I could not be stopped. I cannot start doing that. I would get addicted to unstable features. Yes, we need remainder on our matrices. I'm just imagining the next month of my life rewriting this again with the array-backed vectors, const generics. The stable kind of const generics. I also don't know, is it better to have an array 2D type? Well, I guess you do need that. Yeah, no, you do. I do need that. So I could make it like the matrix where it takes a T and then it's like array 2D of array like this. I could do that. And it's just like, I'm 2D. I have cool 2D functions. Because the problem is like this. Oh. Yeah, no, it'd be this F32. Whoa. T. Whoa. Whoa. Cool. So what was it? It was dot. So if you have dot in array, an array can hold any T or something, and then you put an array inside of an array, are you doing a dot across the inner things, or are you doing a dot? I guess like, what, you have two matrices? It's too hard to show with my hands, but like you can do the rows or the columns, and like there's different ways to do it. So you need to have a separate type. I figured that out. But then should I do it like this? I don't know. I feel like this would make it simpler. Type array equals array. Yeah, so the problem is that if I want to have dot with the same name, it means something different for matrix multiplication. If you have an array of arrays and you dot an array of arrays, you're like multiplying component wise and adding it together, and that may not be what you want. In fact, it's almost certainly not what you want. You want matrix multiplication. Because like vector 3 times vector 3 is defined as just like component-wise multiplication. So you need to somehow have a separate type. So you may as well have it like compacted in there instead of having it nested like this.
Matrix 3, vector 3.
Does that? Yeah, no, that does make sense, because then you have access. So for the deref type, it makes sense. To have the matrix generic across the vectors. But for the array, I think this makes more sense, where it's just one type and it doesn't have a T inside of it, a T of arrays. Before I started making this library, I was imagining like, what if you could have some sort of elegant implementation that uses like an inner dot product and like it like dot products the dot products and it comes out as matrix multiplication, but I can't really see how that happens. Myself, I've never wanted to invoke array2d dot array2d. Yeah, but like the point of this is that the type it's okay, so it would be like this 2D. The point is that it derefs into a different type when you try to access the x-axis. So like it quacks like a matrix, and then when you go to look at it, you can just like edit the axes by name, and it doesn't matter that it's a weird wacky array thing, because you don't ever need to like do a loop across the array to get the components. I mean, like, you're supposed to do dot products and stuff anyways, and like never access the components. Totally private vectors. Private fields. Opaque vectors. You could do that. You could make a vector library that's completely has private fields, and you have to like use general things like dot product with like the y-axis or something instead of the vector the y component of the vector. And that's another thing. Oh my god. I am like on a tangent, on a tangent, on a tangent, streaming on a tangent, on a tangent. This is the problem with having no restrictions anymore. When I was making Roblox games, it was just like, oh, you can't do that on Roblox, and that was the end of it. Oh no, Roblox is too limited for that. We can't do that. And then the idea ends there. Whereas if this, I'm like planning 5 years into the future, and like, oh, when I encounter this situation in 5 years, I could do this. There's no limits. I can do anything. Map 44 equals matrix 4 vector 4. Specific matrix methods. Yeah, I think it's necessary. That's what I ended up with for this library after weeks of fooling around. T. Let's put T in there. I'm gonna put T in there. Let's go. T's going. T's going in. T. 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 T sum? T mul sum? Oh, I guess, you know what? Let me see this. Hold the phone. Can I do this in a stupid goober way? T. Where T mul SCD ops mul and SCD iter sum. Right? T. Oh, two generics. Oh, T. Array sum. T as mul output. Oh, okay. Yeah. No. So where? Oh, oops. T. So then you go one further and you go T as mul output. Output has sum. T as mul output. STD iter sum. Oh, it's like that. Okay. Do it. Do it. Do the thing you just said. Oh my god. Okay. Okay, it's like this. Yay. Okay. Array 3 T T. 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 We good? Let's go. T. T. Uh-oh. Okay, fine, whatever. T. T. Uh-huh. T. Then close this, open a new one, and bring this bad boy down here. Uh-oh. Yeah. T, T, T. Oh, I could actually do even better here. I could have TU. Do I care? MLT indices being tracked by template arithmetic for time, speed, velocity? What? Dimension checking. Hoo-hee. What? The solution to C++ problems is C, not Rust. Unusual. Oh, a coworker went on to do full dimension checking. Yeah, I've thought that's a cool idea as well. Dimension checking kind of ends up as, well, I mean, how many are there? There's like six like SI types or something. And you could like have all those generics, but type safe physics. Wow. 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 Okay, RHS. We can have TU. TU. T multiplied by U equals V. So T is mul U. And then other is array NU. And then uh-oh. Okay, I don't need this. I don't need this. I don't need this. Backtrack. Okay. T. F32. Where is it? There it is. Ah, there's your problem. 0. I wrote this funny. I was lazy. I just did a transpose. Can I go like this? No. Expected value. Is it maybe uninitialize? Cannot move out. Non-copy. Oh my god, okay. Okay, I give up. I'll do it in the library. No T here. T. Yeah, get out of there. Ah. So this is T. Array 3 F64. Well, that's cool. Hell yeah. But then you go to the array 2D and it's harder. I guess I could directly impl. That'd be fine. Go like this. Now we can add T. 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 Ooh, T. 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 Yay. Yeah. T. Hell yeah. Okay. Jump over all the hard parts. What is he complaining about? Oh, functions never used. Yeah, whatever. T. Is it all just T? It's also the repr C. Did this get bad? No. Nice. Okay, let's do rep. Okay, that's repr C to avoid UB. Yep. And then yep. Uh-oh. Is that gonna put it right in the middle? Bruh. Bruh. Okay, and then put it back. D. Let's go. Okay. Okay. Try doing a fully generic lerp. Really? Wouldn't you just... Well, yeah. Rust didn't have const generics. I see. And now it still doesn't. It has a subset of const generics. Neat. Some output. Wait, F64. Oh, it's. Oh, I made everything T, and there's no longer distinction. I guess it defaults to F64. Huh? Who knew? Magic. But then this one is F32? Interesting. Huh. The blend factor being an integer fraction. Yeah. So I want that form for specifying a length for a vector. So I'll go like, I want to use this vector as the direction and set the length to this, and the length can be a fraction. And I think that's useful because if you're moving really fast, high velocity, the time steps become less precise. So you can't just solve for time and then evaluate your trajectory at that time and have it be precise. You need to have the time be a fraction. Types only flowing forward. Yeah, in Rust, it has to be, they can flow forwards and backwards, but it has to be unambiguous. It'll like detect when there's an ambiguity and like require you to specify. There's no auto. I guess except in this case, where like, because like if I do this, F32, now everything's F32. Let's go. What if I say this is F32? It should just figure it out. Yeah. I think it's cool. I didn't expect to do this today. Less abstraction hungry. Really? Rust is all about like zero cost abstractions. What about the mental cost? Everyone always talks about the performance cost. There's no performance cost. Wow. So this would be so easy to set up with macros. I just have my like types. It just derefs in those types. It's so good. It's so good. Yeah. This is it. I think this is it. I was debating about like array of array, but I think this is it. I think it should be a matrix of vector for this. But I think array 2D will be better than array 2D of array. Yeah, that also like sounds weird. Wait, this is just saying this implementation only exists for F32. The function call is the type bound? What? That's wacky. Nothing else specifies. Huh. Oy. Man, I'm very pleased with this. Very, very pleased. So pleased that I might spend another month writing this library. It's really fun to write as well. When I wake up and write a crazy macro that like even I don't understand, Deref. 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 I can only deref into one type. It's kind of like inheritance. Totally not inheritance. Rust program is more maintainable as the restrictions it adds. To organization? Composition over inheritance? Deref. Deref. Huh. Deref. That does it, huh? Totally not inheritance. No, gosh. One word got me thinking. Template is more powerful than Rust generics. More people hate it. Yeah, so I've heard. So now I'm thinking about this. Ooh. This thing I was looking at over here, where I have these IDs, and they're type wrappers for type safety, and I have hash tables. Where's physics models? So there's a bunch of freaking hash maps here, and they go like, ah yes, the physics mesh ID maps to a physics mesh. So let's just say U32. Same with this, same with this, same with this, same with this. And they're just wrapped U32s to safely exist in a struct and only refer to a specific class of object. And hash map, that's really easy for hash map because you can just put it like this. But for vec, when it needs to index, when it's like, when there's no holes, and so you can have a vec, you can't index a vec by this random type. But with deref, I could have a new type around the vec, and it derefs into a vec. Does that like, that is so close to inheritance. Wow. Funny. But sometimes you just need to inherit everything. You just want a different type that's the same type. I wish I could have that. I wish I could just say new type walk settings, and then that's it. It's like literally exactly walk settings, but it's a separate type, treated by as a separate type by the compiler. That would be nice. New type U32. What else can I do today? So I wanted to do the matrix multiplication macro, and I did that in like an hour, real quick. And then I also did determinants and the adjugate matrix for 3x3. But now I think I want array-backed linear algebra. Because they'll be less insane with the macros. And I checked that it does loop unrolling. But I think that's like a job for another day, another month. This month. Yeah, I mean, it's kind of opaque to deref into this. It's opaque that you can do that. Because there's no properties that say this. It's kind of bad for a library. Because like it's opaque because of all the const generics, opaque because of all the macros, and then like the actual utilization is opaque. I've always been a fan of complicated implementations, simple API. And this does fit, but it's nice that a lot of REST things are self-documenting. Type signature. Hmm. 7 hours. I've been working on this thing for 7 hours.
Bruh.
It's basically a fresh start. It's like const generics world instead of macro world. Bruh. Everything is a race. Everything is race. There's got to be a better way to do this. Let's see. Where's the chat? A T N This song is awesome. I can hear the future.
Oh, this is the same session. Where the hell? Okay. For loop. Oh, I see. That looks simpler. I guess probably the compiler can do that. Bounce check. That's nice. That's what I was looking for, basically. Curious. Oh, I guess I should write it. Some. Can you multiply like this? No. T wasn't copy. What? The old way. Oh, into iter. I see. I see. Array from function. Yeah, that's cool. Iter once. I like that they have these like standard sort of pass through things where there's like the identity function where it just takes the value and passes it through, and there's like a you don't have to like define that function in your code or like do like anonymous closure or something. It's the special case. Oh, what did chat say? LHS.mul RHS. Bruh. Really? Copy. Yeah, I don't think so. What? That's. It said something and then wrote code that does something else. Hmm. Easy would be subcommand into a cloud subcommand. What the hell does that mean? Nuked the ability to use the endpoint. Really? That's bad. There's, as far as I know, there's no way to download assets. You just can't. Asset deliver. I mean, do you want to take a look? Cause I couldn't figure it out. I couldn't find a thing. Well, this looks better, but it's worse. Oops. T. I am still like reeling from the implications of this trait. What happened to this code? T. Why do I do this all the time? I get just entranced by the code that I just wrote. I'm like, wow, look at that code. Wow, that code. Oh yeah, I have all my, I have to like do the pull request stuff as well. Unions, adjugate matrix. I wrote all of it. Actually, the code is probably exactly the same because of the deref shenanigans. Golly gee. Adjugate matrix. Conjugate. Adjugate. It was so close. Things were so close. I had almost escaped from the fixed point library implementation. I was just speeding through, just absolutely macroing the bejesus out of everything. Deref. Ugh. A matrix library that can do it all. Generic. Named field access. Golly golly. Why don't I do this right now? Okay, so he said that it's in doc. Where is it? Doc mod. Bit. Do it. Bit. Bit. Oh my god, bro. Bit. There it is. Bit. Set. Bit. Set. Bit. Oof. Okay. Okay, what? There's not a lot of mutable functions. Swap. Shifts. Okay, so mutates the bit in the given position. If value is true, hell yeah. Okay, I need to make some frickin' doc God damn it! Documentation macros. Oh my god. Okay, so dot bit. Okay. Okay, so uh-huh. So it'll be like mute n dot set bit. Let's see. Least significant is 0, most significant. Okay, well this is the least significant. So 0, 1, 2, 2, false. And then assert n dot bit 2. So we can actually do slightly better than this. We can go assert n dot bit 2 and assert set bit false, assert n dot bit 2. What is that? Assert the, okay, we can just remove that. Hell yeah. Let's go docs. Unused? Alright. Oh, what frickin' branch am I on? Bunum. Uh-huh. Set bit. Easy clap. Okay. Where is it? Set bit. Digit from value, I see. Um, Um, what other kind of digit manipulation could there be? If you have a super wide freaking number, 1,000 bits wide, it's an integer, and you want to like, it's like opaque. So usually you have to copy the whole number to do stuff, but this function, inside it's represented as like digits, and they're like 64-bit digits. So set bit goes like, oh, set bit 726. Oh yes, okay, that's here. Change it right like that. Instead of going like copy the whole thing and then like do it or with an entire thing and it like copies giant numbers multiple times. It just takes an existing number, finds where the bit is, and changes the digit. So what else could you do? So there's already digits, mutable digits, mut. Am I allowed to change this? Yes. I will. GitHub stream. I'm out here GitHubbing. How do I test this? Let's see. Can I go here and do, oh, CD, cargo test release. Could not compile. 45 warnings. Oh, it's using weird stuff. Oh, is it latest? Hold on. P.S. I couldn't compile or test this because of the unstable features. P.S. Whatever. I'm cringe. P.S. Any more cool stuff? What's this? New pull request. Just open pull requests. I wanted the map council to review and pull the map fixes, but I also don't want to like go, excuse me, map council, there's a pull request. Excuse me, review this map. Personally, every time. Neat. Nice. Make it send a request to a webhook in the map council channel. I don't know how to do that. Like that's the description of exactly what I want. const. Let's go. Oh. Look at this. Let's go. That's my feature. Yay, pull requests. Yay. I got that habit from Relix, working on Scream Stream. He'd always go like, yay! Cool. Well, 7.5 hour stream, pretty good if you ask me. I came up with like some cool, super cool new thing. Cool new thing. I think this is, I don't know, like loop unrolling versus macro expansion. I guess slow demo. I guess like the compiler knows best, right? So like if you have a like 20 by 20 matrix and it unrolls the loop, that's 400 operations. And it's probably just faster to load the loop into memory and then run the loop with like a couple extra operations than it is to like load all 400 instructions and like wait for it to come from memory. Or possibly fast. I don't know enough about CPUs to make any meaningful guarantees about that. Let's see what you were doing. Oh, is that my voice? Webhooks. Let's go. GitHub mobile. Right. Payload URL discord.com. Webhook whatever. Who can do this? Maybe someone else can do it. I didn't give you access to the repo to try to like segment the jobs and have like these people do these jobs, these people do those jobs, so that you're not just like overworked doing everything. You're like the quality of life feature guy that like implements interesting quality of life features as you see fit, instead of the bhop everything, do everything guy. I do like designated jobs. Everything has its place, and there's a place for everything. So like, does Discord like just like do something or what? How do you know like what the webhook is? I've never seen anything about webhooks before. Oh my god, I love how generic this code is. So basically it would be just this. And then there'd be a bunch of implementations bruh. God, I love type safety so much. I love it. So few mistakes. All right. Well, I'm gonna end stream. Great day. Everything is so interesting. I just can't get enough of programming. It's so fun. There's so much to explore. Found out something new. Made up something new today. Super cool. Yep. I have to do this. Okay. Okay. Goodbye, all. I will be back tomorrow and possibly start rewriting the library that I just wrote for the past 3 weeks. Let's go.